Hi everyone, welcome to my seminar about the GBA. It has, its CPU is an ARM7 DMI at 16 MHz, which supports both the ARM and the thumb instruction sets. It doesn't have an FPU or SIMD or the newer thumb 2 instructions though. No, it's from 2001. It has 32K of fast IW RAM and a bunch of slow EW RAM. Its graphics is, basically a SNES with a few extra features. It also has 96K of memory mapped VRAM. It also has what's called a BIOS, which is basically a ROM containing a few useful routines which you can use. For the assembler, you probably want to just use the GNU assembler. There's DevKit ARM which contains it. It also has a tool called GBA Fix, which you can use to fix the cartridge headers if you want to run stuff on real hardware. For hardware documentation, you probably want to use GBA Tech because it's very extensive, and MGBA is probably the best emulator out there to test your code. Now, when you get started, you'll notice that the cartridge header is actually quite large. The entire thing here is 192 bytes. And of that there is this 156 byte area, which is Nintendo logo, which has to be there, and it has to be these fixed bytes. That's not really great because it uses a lot of space. So what I usually do is I make one version that fits within the size limit, where I just put whatever code I want there, which will only work in an emulator. And then I also make a larger version, which will work on real hardware. Compo organizers have usually been okay with this, so that should be safe. There's also some other stuff that should be fixed, but details. Now, when your code starts running, it starts in the cartridge memory area. That's actually quite slow because it's far removed from the CPU. So what you actually want to do is to copy everything into the IW RAM I mentioned earlier. Doing that is best done using one of the BIOS routines, but then you can also use the BIOS routine for decompressing using LZ77. And after that, you can actually immediately do a thumb mode switch to jump to the decompressed code, which is probably the best way to save a number of bytes. For the graphics, as said earlier, you have basically a SNES, but instead of only tiled backgrounds, you also have bitmap backgrounds, so you can get a frame buffer. There's many sprites you have. There's mode 7 effects, there's blending, there's mosaic effects, lots of stuff. For H-blank, don't use interrupt, just erase stuff. And the video mode and most of the things is controlled with a single register, which is unlike the sound, which needs lots of more stuff to init, and practically you're only going to use the Gameboy stuff, PSG, because the PCM audio needs even more setup, which is just not feasible, so don't bother. For some example code, here's an intro I made not so long ago, which in the release archive contains the source code. It's basically the front background containing the text with a background containing the random VRAM data. It uses mode 7 transforms to move the front things around. It does that during H-blank, and it's not that complicated. So that's it. Go make an intro.